My name is Bennett Meares, and I will be finishing my senior year during the summer and hopefully continuing with CEVAC as a graduate student in the fall. If you've seen my previous presentations, then you'll know I'm the CEVAC data engineer. It's my job to handle the large amounts of data that we have. But for those who haven't seen it, allow me to give a very brief overview. The core principal idea behind the CEVAC system is the idea of a pipe. Now, when I say the word pipe, the important keys to remember are the building that a pipe is in and the metric. For example, would be temperature data for the metric within the watt center. And I've shown in the graphic on the right a better way to demonstrate how we break down these large amounts of data into smaller sets for us to analyze. For the purposes of this presentation, I've broken down our process into 4 distinct stages: retrieval, caching, management, and access. If you think of the CEVAC system as a mining operation, then the retrieval stage would be us physically going into the mine and extracting the ore. This instance, I have Johnson Controls data, Schneider Electric data, Wi-Fi data. And we're going to all these different places and retrieving that into our standard interface system. The second stage would be our refinement stage, where you refine that ore or that data. And I have this shown here as our caching and aggregate system. So after we pull it in, we mold it and we work with the data. The third stage, our management stage, which I've shown in blue here on the bottom right, that's what orchestrates the entire system. So if you're running a mine, you need somebody to tell which truck goes where and who does this and who does that. The management system lets us keep everything in an orderly process. And then lastly, what I've shown in purple is our access stage. That is, how do we distribute, once we've taken this ore and refined it, this data, how do we provide it to our consumers, whether that be internal CEVAC employees or facilities or billing, or potentially students in the future, as you've heard from Kartik. So this is a quick peek into the CEVAC administrative console. You've seen various versions of this over the past few months. This is our gateway into actually managing, pulling the levers, pushing the buttons, and making the system behave how we want to. Now, this is usually what Tim sees, but this is usually what I deal with. This web console is a direct link into our backend system. So every time you click a button, it executes a command that we have on the backend. Now, there are so many features I'd love to get to, but for the purposes of time, I just want to highlight 3 specific ones. Please hold your questions until the end of the presentation, but I'd be more than happy to answer them. Firstly, I'd like to talk about is the Johnson Controls Metasys API that we've built on top of. I'd like to thank facilities for working with me since December on getting this up and running, and helping provide us with that Johnson Controls Metasys API license. I've been working on this for a long time, and I'm really excited to bring it into production. But the main idea is, if we want to know the state of a pipe, remember a pipe is a building and a metric, rather than waiting on that historic data set to update, we can request on demand exactly the state of the pipes. So what I have here is FIKE CO2 sensors. And what's happening now is it's interacting with the API, which then pings the sensors. So when I click view live, this is the readings as of 10/39 for CO2 sensors within FIKE. This lets us bypass the historical set and the Johnson Controls historian and get a better real-time sense. So if there's a problem with temperature or with anything that goes wrong, we can catch that much more quickly. The second thing I'd like to talk about is our complex pipes. Not only are we pulling the raw data, which is certainly the useful first step, but when we pull in a pipe, we are able to chain together complex aggregations. On the left here, remember a pipe is a building and a metric. On the left are all of the standard building names, and on the right are all of the metrics within that building. I'd like to highlight just a few metrics here. So this S energy metric, the S stands for Schneider, are the meter readings from Schneider Electric in kilowatt hours. Fairly simple and straightforward, easy to maintain. But you may notice that there are S energy month metrics. That is, we can aggregate this data on a monthly basis. So this would be S energy data aggregated by month for the purposes of comparison. So if I look at the structure of this data set, it would be for a given month, say for the month of April, the Academic Success Center used 16,600 kilowatt hours for a running total of 2.5 million. And this lets us see on a very large scale the building's performance month by month. But you may have seen that S energy month billing one, and let me switch to the all building. When I say all, that encompasses all of the metrics as if all the buildings were one building. When I look at S energy month billing, this includes all of the billable meters billable electrical meters, I should say, in this instance, for all of campus. So let me show you what this data set looks like. So in this case, we have the fully qualified name of that meter. So this would be a Cooper meter. Here's the ID for that. And the billing period begins at midnight on the 16th of a month and ends at the very end of the 15th of the next month, or in this case, the latest in the month up until the 15th. So if I go down to March, you can see it begins in March and ends April 15th. Just like that previous data set, we can see the monthly from the 16th to the 15th usage, as well as the running total that the meter set up until that point. I hope this is the final push we need to fully automate all of the Schneider electric meters for billing purposes. But there are many more meters just than electric meters, and many meters still need to be read by hand and entered into the system manually. And we still look at that data and take it to account. And another complex pipe that I'd like to demonstrate is our utilities pipe, which includes all of the meters and all of the metrics. Now, this is one of the more complex data sets that we have. This takes the direct meter reading. So if somebody walks around with an iPad, looks at a meter, punches in the number, even if that meter has a rollover, we take that into account. And this is organized, remember, building and metric. So this will be Academic Success Center and chilled water in KBTUs. And we can see the change from the previous month as well as the running total to that point. This is a little bit more visual, a way to visualize this data set. This gives us that huge big picture building level monitoring capabilities that we need. So for example, if I look at, I don't know, I guess water usage in Barnett, we can see the bottom one is the total meter reading accounted for rollover, and then the above one is the month-to-month change. Now, all of that being said, there are many, many more features I'd love to get into, such as how my API structure is designed and how we're going to be connecting that into further application development. But for the sake of time, I'd like to end it there. If you have any questions, please ask me after the presentation. Thank you for your time.